Okay. Hello, everyone tuning in. Thank you for joining our webinar on AIOps and telecom today. My name is Ahmed Mokhtar. I'm the founder and CEO of GreySkies. It is a pleasure to be with you here today. Let me share with you my screen. Start. I think everyone can see my screen at this point. Okay, the webinar topic today is about revolutionizing telecom with cutting-edge AIOps. What does that mean? We're going to be together for the next 20 minutes, talk about this, and hopefully have some questions at the end. And if we can have anybody interested to have a breakout session with our team, we'll be ready to support as needed. Let me tell you about GreySkies. GreySkies offers cloud-native software solutions for the telecom AIOps service assurance market. We're based in Seattle, and we've started offering these solutions since 2016. The product and solutions that are currently deployed in multiple leading fixed and mobile network operators and have been for the last few years. We've had many success stories, and we'd be happy to share with you these stories. In general, just to set the stage, let me just go over what traditional service assurance has meant at many service providers. The industry had was built on this FCAPS framework, which is fault, configuration, accounting, performance, and security. And these systems were built for networks many years ago, and these networks were not as sophisticated and complex as they were today. And so you ended up with lots of siloed systems for performance, systems for fault, systems for configuration, and so on and so forth. And not only that, a modern service provider today has different network components or networks comprising their end-to-end services, including mobile networks, fixed networks, enterprise, telco cloud, Wi-Fi. I mean, so many different networks. And imagine each one of those having separate fault, performance, configuration systems. This results in many systems that don't necessarily always talk to each other, results in poor service management due to the lack of the end-to-end service availability. Obviously results in high capex and opex because you're buying so many things, and in the end you're not able to tie everything together. And more recently, many solutions started coming online that tries to bring things together. However, still in perhaps maybe across domain, but in functional form. So things like end-to-end performance systems or an end-to-end fault system, but not configuration, fault, and performance together across the entire ecosystem. And so we ended up having these discrete systems that in the middle of a fire drill where you've got network outages, you're trying to figure out what's going on, who's responsible, finger pointing, you have a war room and a knock, and really was quite a chaotic situation, which would end up in an extended mean time to repair, longer outages, and the customers being affected. At GreySkies, we're really looking at technologies involved, and we're looking at really bringing all of this together into one platform. And not only that, but also leveraging the new principles of AIOps, which we're going to discuss in this webinar. So just in general, what is AIOps is the idea of leveraging artificial intelligence, machine learning, and big data to enhance and transform IT and network operations. So a key concept here is that we talked about FCAPS, fault, configuration, performance, etc. We look at this as we're collecting data. We have to have a data mindset. These are all data points. It's great that it's performance or configuration or that's all. You know, this classification is important, but for us, it's all information that we want to bring in. Once you bring in all this information, what do we do with it? How do we enrich this data that we're collecting with the proper metadata tags so that we can build and stitch this end-to-end visibility across this network, and then start to leverage these new technologies to make operations more efficient, reduce outages, and make customer service, improve customer service in general. And so once all that data is collected and we ingest it into our system, we enrich it, we organize it, and you can dashboard it, you can report on it. And most importantly now, what do we do with it? And as everyone knows, data is the new oil. So we need to really leverage this data that we're collecting. And this is where AI and ML comes in, where you start exploiting the structure within this data to correlate it together and to bring different aspects of the network together, whether it is customer views, whether it is network views, whether it is service views, or it's business views, bringing it all together and start to leverage the new computational abilities of our platform to gain insights, to reduce mean time to repair, to remediate. A key side benefit to all of this is that while our system can be an umbrella system that integrates with the platforms that are in place, you can over time consolidate these legacy tools, retire, use our platform to start collecting the data natively from your devices or your NMSs, and in the process, you end up saving on CapEx and OpEx, and this is some of the things that we're going to discuss as well. So from our systems perspective, and from in general, a story perspective, so the first thing you want to ask is always, what's going on in my network? And this is the foundational layer that is critical to any network service provider. You want to collect network element KPIs, you want to collect alarms, you want to collect configurations, but this is at the network element level. This is a router, an eNode B, an enterprise Wi-Fi node, whatever it is. And this doesn't speak to the service, what is riding on top of this infrastructure. But nevertheless, this is important. It's table stakes. You need to have that, and you need to have that across all of your domains in the network. Not one mobile, not 5G use case, so an operator, in the end, this needs to be a practical platform that really helps your team. So universal, we need to cover everything in your network. Then we talk about layering the service layer on top of that. What kind of service is riding on top of this network? And a telecom service provider has so many services these days, ranging from IP MPLS VPN, 4G and 5G mobile data, voice over LTE, VoLTE, lots and lots of services. And all these services are riding on top of these network elements. And we need to start to understand what is happening to these services end to end. And so these two steps are critical, and many operators have this type of view today. Not all of them, but many. We see that in quite a few cases. The interesting thing starts layering on top the next set of information that such a big data system can enable, which is customer experience data, whether it's from probes, whether it's from DPI, whether it's from whatever data source it is within the telco. Typically, we like to focus on the DPI. We want to start ingesting that to show what is the real customer experiencing on top of the service and the network. And we layer on top of that the active probing, which is these virtual probes that are sitting at strategic points in the network that are testing actually what would the customer experience, how would the customer experience my network if they were doing this video upload, this Facebook post. And we're talking about fully customizable type of tests, workflows that you can really simulate your customer behavior at different points in your network, so that in addition to now seeing network, service, what the customer is actually seeing, what the customers would see from my perspective by running this test on a recurring basis and understand the consistency and behavior of my network. And then on top of that, how about asking our customers, where are our customers complaining? The last thing many of the operations directors want is receiving a phone call saying people are complaining and they're not knowing what's going on. So Having that visibility, integrating with the customer CRM and customer care logs, ingesting that data in, should validate and confirm and make everyone focused on where to solve that problem. So I see where the complaints are coming from. And then finally, we're hearing from many of our customers as well, discussions about crowdsourced data. There are lots of feeds, things like Ookla and Down Detector, etc. And these provide crowdsourced data with that will reflect what the world is seeing about you. And this is a consolidated feed that will have lots of KPIs and metrics and consolidation of social media feeds, which layers and completes that picture. Once all that data is collected, that's why we're talking about collecting data. In here, we see KPIs, alarms, logs, configurations, customer experience, business metrics, customer care logs. All that is information that we want to ingest into the platform and start to pass on to dashboards, reports, and to do the really fun things such as automation, remediation, self-healing, analytics, and correlation, which is the core of this discussion. Now, AIOps. What is the principles of AIOps? AIOps is a term that sort of came about a few years ago and primarily was focused in the enterprise space. And what we're seeing here is that these principles can be really carried over into the telco space. And this is what we are focused about. So what are the key characteristics of what AIOps is? AIOps fundamentally has these critical 5 characteristics you see in front of you there. Cross-domain data ingestion and analytics. I think you can see that from the platform, from the previous slides, is that ingesting data from multiple domains and the ability to analyze this data is critical. How do we analyze this data? There's 2 ways of doing it. I want to analyze this data in real time as it's coming in at the point of ingestion, and you want to be able to do historical analysis on the stored data. That's the first thing, is that any AI platform must be able to collect data from everything and must be able to, from every possible source, and must be able to do analysis on it, either in real time or in a historical mode. The second thing is data alone is not enough. You have to understand the relationship between the different components of this data that's coming in. So topological relationships, implicit and explicit. This node is connected to this node. This service is riding on this network element. What is the end-to-end path for a specific service? What does a customer transaction, how does it ride my network and where does it go to? Understanding all these relationships and inferring it and sort of absorbing it into the system so that you can leverage that in making intelligent correlations, providing the right insights is critical. So providing data that is not tagged and not tied to each other is essentially useless. It becomes a big burden. So having that topological relationships inferred, assisted, and provided is really a critical capability for this concept of AIOps. Well, once we've done that, we have all this data, we have the topology, we have the relationships. Now we can start to look at doing, the platform should be able to do the correlations between the different events that constitute an incident. So alarms coming from different parts of the network or different parts of the service are often quite related, or KPIs degradation is often related to configuration change, related to an alarm from a different part of the network. We start to be able to correlate and to combine the time and topology to group into related events. Once we've done the correlations, now you start to see the patterns. The system will recognize these patterns and to detect these incidents and to localize what the root cause are. So we should be able to process the service, the network, the customer information all together to start to understand and develop these patterns that we need to recognize to be able to understand what is going on in the network. And then finally, once you've done all this, you want to be able to remediate. You want to be able to fix. If there's an outage, you want to be able to address an automated response to it so that you can improve the customer experience and reduce outages, reduce mean time to repair. These principles have been obviously articulated by Gartner in their reports in around 2016, and this has been obviously an ever-evolving field. But you can see from that definition and what the GreySkies platform is capable of and what we talked about is that this is exactly what we do. That's why we are focused on the idea and the principle and the offering of bringing AIOps to telcos. And there's different ways of doing this. There's lots, so you can do it in parts of the network, not all, but we're really trying to bring that methodology, that to have AI, ML, big data infused within every aspect of our system to leverage this technology to make network operators more efficient. So a key component on this relates to the analytics platforms that the components that we have within our system. And there's two of them. Going back to the definition, there's the real-time analytics streaming, real-time streaming analytics, sorry, and intensive complex data analytics. One operates the data at the point of ingestion at the resolution of seconds and minutes and 5 minutes. Scalable, leveraging real-time anomaly detection of data, what we call in motion, and uses univariate, multivariate anomaly detection model integrated within dashboards and reports and workflows and automation, and you can trigger based on that. And we have lots of use cases to talk to you about that as well. We're not going to get the time today, but hopefully we'll be doing that at different venues with you or different opportunities moving forward. By way of the analysis of data on the data at rest, we have the intensive complex data analytics platform where it's a batch processing system that operates on hourly or 6-hour or daily schedules or weekly schedules. Really compute intensive data analytic jobs for analyzing data at rest. These two capabilities are critical at point of ingestion and at rest. And there are lots of use cases that will require one of these two capabilities. The use cases that we're talking about, and we've, if you've seen some of our previous webinars, and things like correlating subscriber metrics with service and network performance in, for example, a service like fixed broadband internet, or for 4G, 5G mobile broadband data, or understanding and correlating the specific paths and the customer experience as it relates to traversing from the radio network to the backhaul, whether it's microwave or optical, and then to the aggregation layer. Use cases like energy management and optimization, very critical, and this is a whole subject that we can have a separate webinar on in terms of how important this topic is given the level of energy consumption that operators are seeing right now, especially with the introduction of 5G and eventually 6G and the artificial intelligence workloads that are coming on to data centers. How do you have great visibility into it? How do you optimize it? How do you measure it? How do you measure your CO2 footprint, costs? Lots of a very interesting use case. Telco cloud and infrastructure performance and automation. Very complex infrastructure in general, moving from virtualization to containerization, workloads running on large data centers with different layers, and you want to be able to correlate across these layers to understand what is happening in your network. And then finally, a case like multi-domain capacity planning, where you're taking a service, like fixed broadband service, and you're doing capacity planning end to end for it. The data that we're collecting has tons of relevance to making the right predictions as to what's going to happen, how much capacity I'll need moving forward, and leveraging forecasting algorithms and big data there to do this job right is a critical component. So the key thing here is to say, it's not just to do these use cases for the sake of it. What is the measurable impact of building or leveraging AIOps in a telecom environment? It's not about just saying we're using this technology. It's really about translating all that to measurable business outcomes. And so we are hyper-focused when dealing with our customers on what is the ROI for this specific use case. So we're showing you here a few use cases tangible results and outcomes that we've seen working with our potential customers. In some cases, it is service assurance budget OpEx reduction. By consolidating many tools, we have, for one of our key customers, reduced their OpEx budget by 56% because we ended up consolidating, layering the system as an umbrella, and then slowly consolidating tools to save on their budget. In another case, operational efficiency, where our system was able to help that operator reduce the second level technical support calls that are being received, because we're leveraging automation to fix the problems before the customers call in. That resulted in a 23% in call reduction volume. What does that mean? That means immediately money savings right away, right? Because it's the staffing levels that you have in the call center. It's the customer satisfaction side of it. All of that. This call reduction is a good thing. We would like ideally to have 0 calls coming in from a technical support, because the network is dealing with everything, and the systems, the assurance systems, are addressing the problems before the customers can feel it and report on it. In another case, we have a mobile network operator in case 3 here that is offering MVNO services, where there are other operators that are riding on top of that, on top of them. And in that case, there is an obligation, there's service level agreements that have to be met, and there are penalties if you don't meet these SLAs. And our system was able to reduce the level of penalties that an operator had to pay, because we're able to help them meet their SLAs on a more consistent basis, reducing, and this is again, reducing penalties is ROI and money savings. The most important use case and what we're talking about here is primarily the issue of the revenue loss avoidance. By infusing and collecting the data and organizing it right and getting to the problem quicker, reducing the mean time to repair, results in reducing what's a very important metric for many operators, the network unavailability rate. That network unavailability rate, if you reduce that number, you automatically reduce your revenue loss and any losses, because the customers are constantly using the network, whether it's for calls, for voice, for whatever, for data. You reduce the network unavailability rate, you improve your overall revenue. And that number we've measured with one of our key customers, and we've shown that our reduction in the MTTR and the mean time to repair results in a 2% revenue loss avoidance, which is a significant number. We're talking about billions of dollars in revenue, and so even saving 1 or 2% is a quite a meaningful number. Let me see. Couple of slides just to give you a sense of what this means. Multidimensional observability, some of these use cases we're talking about here. Just giving you, before I wrap up, I'm going to just show a couple of quick views and ideas of what we're trying to do, and we stand ready, as I said, to engage with you. Please reach out for a demo, for a meeting. Would be the sales team is ready to support as needed. But in a case like this, we're talking about the fixed broadband service, where we can, as you can see, we can correlate, we can put in customer experience metrics on top of the actual service, layer different metrics to be able to bring that, correlating that subscriber, that service, that network, that business view together. Another use case is for the 4G, 5G mobile edge data. We're able to infer automatically from your network. These are eNode Bs in this case, connected to microwave links, which are cascaded, which eventually backhaul into your mobile backhaul infrastructure and into the core. Just having the inference is a lot of work that we know how to do, and is the foundational aspect of AIOps when it comes to topology and understanding. So inferring all that, understanding all that, and then collecting from customer experience metrics all around this, the eNode Bs, the round trip times, the applications the customers are using, the packet loss, and correlating it with what is happening on this node by way of its different statistics. You start to see we are collecting the eNode B KPIs, the microwave element KPIs, the IP RAN KPIs, and then we're looking at the service level KPIs, and we correlate and understand what is happening in the different parts of the network, and identifying the when anomalies happen through machine learning, and correlating it and pinpointing where the area that needs to be addressed to fix that the problem in this case. A final case to bring this up is the telco cloud case, where you have virtual network functions over virtual machines over compute nodes, and this relationships, and again, service level KPI at the level of the function that impacts the customer, and then the underlying information that we want to correlate together to understand what is the impact on the service in this case, and whether that has resulted in any customer impact, and how do we fix it as quickly as possible. In general, I think this was a quick rundown. We would love to have breakout sessions with the different parties that are interested. We're stand ready to take meetings with you on calls. If you're going to be, anybody's going to be at MWC, we're going to be there in a couple of weeks. We'd love to see you. Thank you for your time. Thank you for listening, and looking forward to interacting with you moving forward. Thanks.